In this video, we learned that how we represent the vectors by using the component. Here we draw the triangle which have two components Rx and Ry. It resultant it we get by tail to the first vector and head to the last vector. Here the vector R that is make angle theta with the horizontal. So here we write that consider a triangle OAB. Here we use the trigonometric function metric function that is the cos theta is equal to base our hypotenuse base that is the Rx hypotenuse that is R. So we can write that Rs is equal to R cos theta. Here we use the other trigonometric function that is the sin theta that is equal to perpendicular over hypotenuse perpendicular that is the Ry hypotenuse that is the R Ry that is equal to R sin theta vector R in term of its component that is equal to R vector that is equal to Rs dot along I unit vector plus Ry that is along J unit vector. So we can write that R vector is equal to Rs that is equal to R cos theta I unit vector Ry that is equal to R sin theta J unit vector. Now we can write from a right triangle OAB using Pythagoras theorem. We write that hypotenuse का whole square that is equal to base का whole square plus perpendicular का whole square. So here we can write that hypotenuse that is the R square is equal to base that is Rx का square plus perpendicular that is the Ry का whole square. In the last we get that the resultant vector R square that is equal to Rx का square plus Ry का square. If we remove the under root, we take the under root on both sides that we get the magnitude of the resultant R under root Rs का square plus Ry का square. Now we determine the direction of vector. Direction of vector. Here we use the trigonometric function in triangle OAB that is the tan theta is equal to perpendicular over base. So here we can write perpendicular that is the Ry base is that is the Rx. So theta is equal to tan inverse Ry over Rx. That is the direction of the vector R.